Hello everyone, this is a video explaining dividing polynomials, some rules for dividing polynomials, and it's in your notes packet, the Exploring Polynomials unit, Algebra 1 packet. I went over this Tuesday in class, but this is a quick video to review those notes again. Just a little reminder at the top here about dividing monomials and the exponent rules that we have to remember. And all four of these examples are examples of the exponent rules. And basically, if you have the same base and you're dividing, you subtract the exponents. So that's what they did in each one of these. Notice they subtracted 5, take away 3, and they got x squared. 2, take away 6, they got a to the negative fourth. And the other exponent rule, another one, is that you can't have a negative exponent. You cannot have a to the negative fourth. So what you do is you drop this to the denominator, make the exponent positive, and 1 in the numerator. That's how they get their answer here. Number 3, they divide the two integers. 20 divided by 4, they get 5. And then they do 8, take away 3 to get the other 5 exponent on the z. Number 4, the same thing. You divide your integers, and you get 3. And then you do 4, take away 7, you get negative 3. And you have to switch that because you can't have a negative exponent. So the b drops to the denominator, the exponent becomes positive. So that's just a quick review of some exponent rules. And then when we get to dividing a polynomial, which is multiple terms, and all of these terms are listed in standard form. This is listed. This is polynomial expressions in standard form, which just means the exponent values decrease from left to right. There's an invisible 1 here. Well, you take each term and you divide it by the denominator, whatever's in the denominator, that's 4x. So they break it out in right beneath here, and that's what they do, is they divide each term in the numerator by 4x. And the x is to the first power, so you have to keep that in mind when you're dividing. Now, when you divide the coefficients. 12 divided by 4 is 3. X to the third divided by x to the first is x squared. That's where that first term comes from. You bring down your plus sign. 8x squared divided by 4x is 2x. And then you bring that one down. And then you do 6, then you bring down your minus sign. And 16x divided by 4x. Well, the x's cancel, and 16 divided by 4 is just 4. And then you take the last term, and 6 divided by 4 is just reduced to 3/2. And then the x will stay in the denominator because there's nothing on the top to divide it by, so it just stays where it is. And that's your final answer. That's how we divide polynomials by a monomial. A monomial is a one-term expression. So this 5x squared, 5 times x squared, is considered one term. So what you do is you break out each of the terms in the numerator and you divide them by the denominator. And that's what we did here on each one of these. And the exponent rules come into play. Now you notice the last term, 10 divided by 5x squared. Well, 10 divided by 5 simplifies. That's where the 2 comes from. Okay, but the x squared is in the denominator and there's no x in the numerator, so you can't do anything with that. You leave it there. I know it looks strange, but that's how you have to leave it. And then if you look at the middle term, the 3x to the negative first, you have to fix that at the end because you can't have a negative exponent. So it drops down to the denominator, the exponent becomes a positive 1. And that in a green highlight is the final answer. The next one, you divide each term in the numerator by 2a. So that's what I have listed here. Each term divided by 2a. And as you can see in the answer, the third term, 2a divided by 2a, is just a positive 1. Okay? Anything divided by itself is always 1. And there's a plus in front of it. So we just keep those signs. We bring them down to the very end expression. Okay? And this is your final answer. So hopefully you're starting to get see the pattern here. Just break it out. Each term divided by the denominator. Okay. So here's the final answers for the next two. Let me show you these. All right. You can hit pause and try them yourself and then see if you get the right answers. Or you can just look at the work and make sure my work is right. Always using the exponent rules. You subtract the exponents when the base is the same and you have division. And if you end up with a negative exponent, it has to go to, if it starts in the numerator, it has to drop to the denominator. If it started in the denominator, it has to move to the numerator, okay? We don't have any of those in these examples. All right, so here are a bunch of try these. We did not go over these in class. I want you to try these on your own. And then Thursday or Friday, depending on if we have school, I'll go over the answers. Okay, so log in and watch the live. Also, these are just more practice of adding and subtracting polynomials, also multiplying polynomials. Again, lots of good mixed practice on this worksheet. You should be able to handle all these, and I can go over all the answers on these as well. This is another one that you should be able to do. You just take each term in the numerator and rewrite it by dividing by the denominator, okay? Just simplify those variable parts of the terms by subtracting the exponents. Should be able to do those. And then here, we talked about this in class on Tuesday, about finding the greatest common factor. I went over what are the factors of 12? Well, it's 6 times 2, 4 times 3, 1 times 12. We're not prime factoring. We're just looking for the two factors that multiplied together give you that product, okay? And you can always check your answer by multiplication. So if we're pulling out the greatest common factor, sometimes when we have these polynomials, in order to break them down, we have to pull out the greatest common factor first.
Could everyone attention please, just a reminder, you may want to take your laptops with you tomorrow or to home tonight, just in case we do not have school tomorrow or Friday, so just a reminder, we'll get to take your laptops with you.
As you can tell, I'm in the building filming this, and we might not have school tomorrow. So do whatever you do for your snow dances. So, greatest common factor. Well, how do we find the greatest common factor when we have a polynomial like this one? It's two terms, it's a binomial, it's linear because the highest exponent on the variable is 1, all that good stuff. What's the greatest common factor? Well, the first thing you examine are the two integers, 21 and 14. And you look at those two integers and you say to yourself, what number divides evenly into both of those? What number is a multiple to get to 21 and 14? Well, it's 7. That's the number they have in common that'll divide evenly into both of those. The factors of 21 are 7 times 3. The factors of 14 are 7 times 2. So their greatest common factor is 7. And because the 21 is the term 21x, and 14 is just an integer, a constant, it doesn't have an x attached to it, you stop right there. That's your greatest common factor, 7. You don't even look at the variable because both terms don't have the same variable. So you can't do anything with that. You just pull out the greatest common factor, and in this case of 21x minus 14, it is 7. So let me show you the next one. So here's one where we have, let me get rid of all this. We have 3 terms, and I look at the coefficients of each term first, which are the integers. And I say to myself, I've got 5, 10, and 15. What is the largest number that divides evenly into all 3 of those numbers? Well, I do know my multiplication tables pretty well, and I see it's pretty obvious that it's 5. 5 will divide evenly into 5, 10, and 15. When I say evenly, I mean there's no remainder, okay? So then I go to step 2, and I look at the variables. And it's got a y, this one has a y, and this one has a y. I say, okay, since all 3 terms have a y as part of the term, big multiplied to the number, the coefficient, I can pull out a y as part of my greatest common factor. And I look for the y with the smallest exponent, which would be this one, with y to the first power. So that's the one that gets to come out and be part of the greatest common factor. And you're done. That's the greatest common factor. 5y will divide into all three of those terms with no remainder. Okay? Number 3, I'll go over this one, and then I will just show you the answers, and you guys can try them and then look at the answers, okay? So here I've got a 3-term polynomial. The highest degree is 3, so it's cubic, and it's got 3 terms, and I'm looking for the greatest common factor. Well, the first thing I look at are the coefficients, which are 1, 3, and 1. Well, what's the largest number that will divide into 1, 3, and 1 with no remainder? Well, it's 1. That's all it can be. So the GCF starts off with a 1. Then I look at each term and I say, do they all have the same variable? Yep, they all have an x as part of the term. So I look for the x with the smallest exponent, which would be this one, and that's the one that gets to come out and be part of the greatest common factor. So the greatest common factor of x to the 3rd power plus 3x squared plus x is 1x, or you're going to see it written as just a plain old x because the 1 is invisible. So the GCF of that polynomial, which is actually 3 terms, it's trinomial, is x, just a plain old x. Or you could say 1x. All right? So that's how this works. And the notes for this are right here. You look for the greatest common factor that divides into all the coefficients, which are the numbers that are being multiplied to the variable. To the left of the variable is your coefficient. And then you look for the lowest exponent. Okay, and you put that in to find the greatest common factor. That's how you pull that out, okay? You can check your answer by dividing that by that greatest common factor, and you'll see, and then multiply them back together, okay? So I'm going to give you all the answers to these. They're all right here. You could hit pause and then look to see if you did this right, okay? But they're there. I wanted to provide this video to you because this is what we did in class on Tuesday. So you can either log in, remember I'm live streaming, and I'm now going to do it on Monday, Tuesday, Thursday, Friday, and watch, or you can watch this little video. Now, the other part that we talked about on Monday was just, we did a quick little refresher of what are, because this is where we're heading. We're going to start factoring trinomials, okay? And there's going to be special situations, and we're going to have to go through the checklist. But one of the things that we need to try to remember are our perfect squares. So some examples of perfect squares are 4, 9, 16, 25. The list goes on. 36, that's 49, 64, 81, etc. Those are perfect squares. And you need to try to recall those. That's going to be very helpful when we start to factor the difference of perfect squares. You'll see as I go through these. But for now, let's hold off on this because I'm going to go over this hopefully Thursday, but as you heard, maybe we'll have some snow. We won't have class Thursday. I'm not sure. But I'm going to get into this more on Friday with the class. So you need to log in and watch on Friday. Hopefully this video is helpful.